In the 21st century, thieves are breaking into files, not metal safes. The mysterious group Anonymous has struck again with a warning that this is just the beginning. There are only a few places on Earth that come even remotely close to Yellowstone Park. There's just so much to it, from centuries of history to beautiful landscapes. The exploration knows no bounds here. But while the world is focusing on the pretty canyons and mesmerizing geysers, something else is going on under the surface, something dangerous that the government doesn't want anyone to know about yet. Anonymous, the infamous hacker group, has just released top-secret information. Yellowstone Park has finally shut down, and something extremely weird is happening. It's something you wouldn't even notice, even though it's going on right under your feet. On average, Yellowstone experiences approximately 1,500 to 2,500 earthquakes per year, and many of them can even be concentrated in a single week. But recently, there have been more and more earthquakes closer together, which has had park officials a little worried for a while. Now that we're seeing over 340 earthquakes, things seem to have taken a turn for the worse. It means that something is going on under the surface, and it's getting more serious as time goes on. When you talk about anything related to a volcano, this is only an indication of catastrophe. While we know Yellowstone as a dormant volcano, there are still low levels of activity going on in there, and with that massive caldera, even low levels of activity can add up fast. That's why what's happening now is worrying. If Yellowstone is experiencing such frequent tremors, it might mean that a major eruption is on the horizon. At this point, you might be thinking that the danger doesn't really seem that imminent because no one's really talking about feeling that many earthquakes at Yellowstone. But that's just the thing, most of the earthquakes the area receives are undetectable by humans, so the only way we even know they're happening is because we've got the technology to be able to pick up even the tiniest of seismic movements. But that doesn't mean there will be a slow build-up to a massive earthquake or an even bigger eruption. No, those can come up seemingly out of nowhere and destroy everything before we'd even have the chance to react. The worst thing about Yellowstone is that it's not just a volcano capable of some local damage, it's a supervolcano that can destroy the whole world. Supervolcanoes are geological features characterized by their immense size and potential for catastrophic volcanic eruptions. These eruptions are much larger and more powerful than typical volcanic events, often expelling thousands of times more material than a typical volcano. Yellowstone is one of them. The Yellowstone caldera is the volcanic feature at the heart of the supervolcano. A caldera is a large bowl-shaped depression that forms after a massive volcanic eruption empties the underlying magma chamber, causing the ground above to collapse. With all the smaller earthquakes, it's only a matter of time before the supervolcano gets to the point of an eruption. The ground might also experience deformation where the surface rises or falls due to the movement of magma beneath. This deformation is measured using GPS and other monitoring techniques, and it's been obvious that something is going on. As magma moves and accumulates beneath the Earth's crust, it generates heat that can affect nearby hydrothermal systems. Hot springs, geysers, and steam vents are all part of these systems. An increase in the temperature of these hydrothermal features can suggest the intrusion of magma closer to the surface. The chemistry of hydrothermal fluids is intricately linked to the geological processes occurring beneath the surface. When magma interacts with groundwater or hydrothermal fluids, it can cause changes in the chemical composition of these fluids. An increase in certain elements, such as silica or sulfur compounds, could indicate the involvement of new magmatic material. Monitoring these chemical changes can provide insights into the movement of magma and the potential for an eruption, which park officials are always working on just so nothing can catch them by surprise. But even then, they know that it's possible for a super eruption to come out of nowhere. The movement of magma can lead to the deformation of the Earth's crust, which can affect hydrothermal features, causing them to shift or change behavior. When the temperatures of geothermal features experience a noticeable increase, it often signifies that magma might be moving closer to the surface. Rising magma generates heat, which in turn affects the surrounding hydrothermal systems. This one's been a little harder to gauge because of the way temperature has been fluctuating due to climate change. Although, from what the researchers in the area can tell, there has been a sudden increase in the past couple of years. Geysers, known for their periodic eruptions, can be particularly sensitive to subsurface disturbances. If these disturbances are caused by magma movement or pressure changes, geyser behavior ends up changing. As there have already been variations in eruption intervals, durations, and intensities of the geysers, there are more than enough indications of it being a supervolcano eruption than a normal one. An observable increase in gas emissions, particularly those containing sulfur compounds like sulfur dioxide, has been noted within Yellowstone. Hydrogen sulfide, making up approximately 0.15% of the gas emissions, contributes to the distinctive smell resembling rotten eggs that can be detected in specific areas. This is a cause for concern because it's associated with magmatic activity. Magma contains dissolved gases that are released as pressure decreases. Monitoring gas emissions around hydrothermal areas is very important and is done in Yellowstone specifically because it can provide evidence of heightened volcanic processes, even without the tremors. But it's the earthquakes that really end up at the forefront. You see, the Yellowstone caldera formed as a result of 3 massive eruptions over the past 2.1 million years. These eruptions, known as the Huckleberry Ridge eruption, the Mesa Falls eruption, and the Lava Creek eruption, have each been incredibly destructive. The Huckleberry Ridge eruption resulted in the actual creation of the Island Park caldera. This enormous volcanic feature stretches across the landscape 47 miles in length, spanning parts of Yellowstone National Park in Wyoming and extending westward into Idaho's Island Park region. The caldera is a massive volcanic crater that formed due to the eruption's colossal force. The eruption of the Huckleberry Ridge tuff, the volcanic material ejected during the event, is considered one of the largest volcanic events ever recorded on Earth. It released an astonishing estimated volume of 590 cubic miles of material. This eruption is especially remarkable because of its sheer magnitude and the impact it had on the surrounding environment and beyond. The Huckleberry Ridge eruption likely unfolded in 3 distinct phases occurring over the span of decades. Each phase involved the release of immense quantities of volcanic materials, including ash and pyroclastic flows. These phases of activity were marked by violent volcanic explosions during which the materials were ejected at high speeds into the atmosphere. But just as it might have seemed that things could never get any worse than this, they did. The Mesa Falls eruption is dated to approximately 1.3 million years ago and is notable as the second most recent caldera-forming eruption from the Yellowstone hotspot. This event resulted in the formation of the Henry's Fork caldera, located west of Yellowstone National Park, specifically in Idaho. It is a key feature in the landscape resulting from the volcanic activity, expelling an estimated volume of 280 cubic miles of material. Even though that's about half of what the Huckleberry Ridge tuff eruption expelled, this magnitude still places it among the largest known eruptions within the history of the Yellowstone hotspot. The eruption's significance extends beyond its sheer size as it contributed to the evolution of the Yellowstone Plateau volcanic field, playing a pivotal role in shaping the unique geological features of the region. The resulting rock formation, known as the Mesa Falls tuff, emerged through the compaction and welding of layers of volcanic ash and fragmented rock. This process created a dense and substantial rock formation that has persisted through time. The eruption's ejected materials added to the volcanic deposits within the caldera, contributing to its growth. The result of this expansion is the Henry's Fork caldera, which measures around 15.5 miles in width, adding to the massive overall volcanic features in the area. The Lava Creek eruption stands out as a pivotal event in the history of the Yellowstone hotspot. It unfolded approximately 640,000 years ago and is recognized as one of the most substantial eruptions associated with the hotspot's activity. The magnitude of the Lava Creek eruption is staggering, with an estimated volume of around 500 cubic miles of material ejected. While this was less than the other 2, it only added to the destruction they left behind. The Lava Creek tuff was formed, and that's what it looks like today too. But what would it really be like if Yellowstone had another supervolcano eruption right now? Well, to put it simply, absolute chaos. Supervolcano eruptions are fueled by the accumulation of vast amounts of magma underneath. The Earth's crust holds magma that can exert immense pressure, leading to the formation of a large, shallow magma chamber beneath the surface. Since Yellowstone already has such a chamber, the initial signs of an impending supervolcano eruption would be next. These often include a significant increase in seismic activity, characterized by a series of earthquakes of varying magnitudes. These earthquakes indicate the movement of magma and the adjustment of the Earth's crust to the growing pressure. As discussed at the beginning of this video, this is already happening. There has been a noticeable shift in Yellowstone's volcanic activity since March 2018. The once infrequent eruptions of the famous steamboat geyser became the norm, increasing in frequency, sometimes happening as often as once a week. It was a regular pattern unlike anything researchers had seen before in recent times. There weren't even any historical records showing this much frequency. In 2014, an earthquake of 4.8 on the Richter scale centered near the Norris Geyser Basin in the park's northwest corner, an area that had barely experienced earthquakes in the past. It was a major cause for concern. But what would it really be like if Yellowstone actually erupted? Unlike typical volcanic eruptions, which are usually impactful but confined to specific areas, the eruption of a supervolcano operates on an entirely unparalleled scale. In the event of a Yellowstone eruption, the initial explosion could generate a shockwave with devastating consequences. The explosion would release an enormous amount of energy in a fraction of a second, forming a powerful shockwave that radiates outward from the eruption site. This energy, similar to the detonation of multiple atomic bombs, is predominantly in the form of intense heat, pressure, and shockwaves. As the shockwave travels outward, it interacts with anything in its path, causing a sudden and drastic increase in pressure leading to absolute destruction. The rapid increase in pressure can cause walls, roofs, and windows to buckle and shatter. Even well-built structures might struggle to withstand the sudden and extreme pressure changes. Trees, being relatively flexible, can absorb some of the shockwave's energy, but the force can still be strong enough to uproot even large and sturdy trees, a devastating scenario especially in a national park. However, that's not even the scariest part about a possible eruption here. A volcanic eruption releases a mixture of molten rock, gas, and ash from the Earth's core. The scale of a supervolcanic eruption, such as one at Yellowstone, can be so immense that much of the erupted material might not even get propelled far from the crater due to gravity and the sheer force of the eruption column. Despite the magnitude of the eruption, there is still the possibility of some lava flows. These flows happen when the erupted magma is so hot that it remains in a liquid state, allowing it to flow like a terrifying river of molten rock. The lava flows from a Yellowstone eruption would likely be sluggish in nature because the molten rock is extremely viscous, meaning it is resistant to flowing quickly. Unlike the fast-moving lava flows seen in some volcanic eruptions, the Yellowstone lava flows would move at a relatively slow pace. This might sound like a good thing for people in the area when it happens, but even then, they'll need to run fast to get away from the lava before it spreads to the entire national park and beyond. And that might not be easy. There are many factors affecting the reach of the lava flows, including the terrain, cooling processes, and the eruption's sheer size. These flows would likely extend only up to around 25 miles from the eruption source. Though the lava emitted during an eruption would be exceptionally hot, often exceeding 1,832 degrees Fahrenheit, this extreme heat would pose a substantial threat to anything in its path. This threat extends not just to people in the area, but also to the entire structure of the national park itself. Even nearby structures, such as buildings and infrastructure, would be at risk if they are within the potential path of the lava flows. The intense heat of the lava could cause combustible materials to catch fire, and the sheer force of the advancing lava could damage or destroy structures entirely, leading to millions in damage. Another aspect often forgotten is that the lava flows would also endanger surrounding vegetation. The extreme heat would cause plants to ignite and burn, adding to the hazardous conditions. While all of this happens, the high temperatures would incinerate or severely damage any vegetation in the lava's path. Wildlife in the vicinity of the lava flows would face significant challenges. Many animals might not be able to escape the approaching lava due to its slow but relentless movement. The loss of habitat and the potential for direct harm from the lava would threaten local ecosystems too. While it's always the earthquakes and the lava that are associated with volcanic eruptions, a Yellowstone eruption of such magnitude would also release an immense volume of ash and volcanic debris into the atmosphere. This mixture of fine particles, rocks, and minerals would be propelled high into the sky by the force of the eruption. Once in the atmosphere, the ash would be carried by the winds over vast distances. Depending on the strength and direction of the winds, these ash clouds could spread hundreds of miles from the eruption site, affecting areas far beyond the immediate vicinity of the volcano. As the ash clouds disperse, they wouldn't just stay there, they'd interact with the atmosphere. The fine particles in the ash can scatter sunlight, leading to reduced visibility and hazy skies. This diminished visibility could affect transportation, navigation, and general day-to-day activities. The effects go beyond the general area and end up affecting the literal atmosphere of the Earth. The ash and sulfur particles in the atmosphere act as a reflective barrier for sunlight. When sunlight interacts with these particles, a significant portion of it is scattered and reflected back into space, resulting in less sunlight reaching the Earth's surface, leading to a cooling effect. The reduced influx of solar radiation triggers a cooling effect on a global scale, a phenomenon often referred to as a volcanic winter. The cooling can impact both daytime and nighttime temperatures, leading to a noticeable drop in overall temperatures. The cooling caused by the ash and sulfur particles can lead to changes in weather patterns. The temperature difference between various regions could influence atmospheric circulation, potentially causing shifts in prevailing wind patterns and ocean currents. These alterations in atmospheric dynamics could result in changes in weather systems and precipitation patterns too, long after the eruption. The reduction in sunlight reaching the Earth's surface can have a direct impact on agricultural productivity. Photosynthesis, the process through which plants convert sunlight into energy, would slow down due to reduced light availability. This could lead to delayed growth and development of crops, potentially affecting crop yields and harvest timings. The climate changes induced by the volcanic particles tend to be short-term, lasting for a span of years to decades. This has happened before too. The eruption of Mount Tambora in Indonesia in 1815 is considered one of the most powerful volcanic events in recorded history. The eruption was a massive explosive event that released a lot of ash, gases, and particles into the atmosphere. The ash cloud ascended into the stratosphere. This cloud contained large amounts of sulfur dioxide gas and aerosols, which were injected to a considerable height in the atmosphere. These particles reflected sunlight back into space, leading to a cooling effect on the Earth's surface. The ensuing reduction in temperatures resulted in 1816 being referred to as the year without a summer. The cooling caused by the eruption was substantial. During the summer of 1816, temperatures in many parts of the northern hemisphere were significantly below average. There were frosts and snowfalls during months that are typically warm, causing widespread crop failures and food shortages. The cold temperatures and shortened growing season led to severe agricultural losses and food scarcity in various regions. Famine and hardship afflicted many communities. The eruption's effects were felt globally, highlighting how a single volcanic event could influence climate and society on a large scale. A century later, the eruption of Mount Pinatubo in the Philippines in 1991 ranks among the most catastrophic eruptions of the 20th century. This eruption also released substantial amounts of ash, gases, and particles into the atmosphere. Similar to the Tambora eruption, the Mount Pinatubo eruption propelled significant amounts of sulfur dioxide gas and aerosols into the stratosphere. These particles remained suspended at high altitudes for an extended period. The aerosols from the eruption scattered sunlight, leading to a cooling effect. The year following the eruption, 1992, witnessed global temperature anomalies, with cooling all over. The cooling effects were noticeable but less extreme than those caused by the Tambora eruption. There were localized temperature reductions of up to 1 to 2 degrees Celsius in some areas. Air travel took the most significant hit, as air travel throughout the region had to be suspended, and it took months for things to go back to normal. However, it's also important to remember that volcanic ash is not only an inconvenience but also poses health risks, particularly to individuals with respiratory issues such as asthma or chronic obstructive pulmonary disease. Inhaling fine ash particles can irritate the respiratory system, leading to breathing difficulties and exacerbating existing health conditions. Considering the world just fought a deadly pandemic that affected respiratory systems, many people are already dealing with respiratory problems, and this would ultimately make it much worse. As the ash settles, it can accumulate on surfaces both indoors and outdoors. This ash accumulation can create problems ranging from a thick layer of dust on streets and buildings to more significant structural issues. Ash can infiltrate ventilation systems, air conditioning units, and other mechanical components, leading to blockages and reduced efficiency of these systems, affecting indoor air quality and temperature regulation. If Yellowstone goes through a supervolcanic eruption now, it would just worsen the climate change that we're already experiencing. So far, we've had extreme winters followed by extreme summers. If the winters get any colder, we'd immediately see the consequences. What's worse is that the greenhouse effect and the duration of the colder times would mean that when the ash does eventually dissipate, we'd see even hotter summers. This would be felt the most in the areas around the national park and the areas where the summers are already fairly hot. The world is already struggling to cope with climate change. Could this be the final nail in the coffin? Let us know what you think in the comments below. If you like this video, please give it a thumbs up, and as always, we'll see you in the next one.